Group one, eyes up here. Just group one. Group two, you keep going. How many of you are on the double number line? Groups? Okay, great. So I want you to think, you were thinking with y equals ax, but what if you add a y-intercept that's non-zero? So what if we have the equation of y equals ax plus k? Would that change the growth of the graph at all? Would it change in terms of, so just talk with your partner, discuss if we add a y-intercept that's non-zero, is that going to affect the growth of the graph? Group two, how many people, group two eyes up here? How many people are on the double number line? Great, great, great. So as you talk about the double number line, think about if we have a y-intercept that's non-zero. So if we have y equals bx plus k, is that going to affect the growth of the graph at all? All right? So keep talking with your partner, talk about if we have a non-zero y-intercept, is that going to affect the growth of the graph? So go ahead, talk with your partner. But it's going to be the same. What did you guys think about
Yeah, because it grows into that.
yeah, so the growth is still going to be the same. We're just going to you guys think about it. Yeah, because the slope is constant, right? But we're just going to All right, all eyes up here? All eyes up here? You guys should be on slide 6, is that right? You guys all see slide 6? Thumbs up? Yes. Perfect. So somebody that did the linear double number line like to talk about, a little bit about what they observed with the double number line in terms of how linear equations grow, linear functions. What about Simon? What did you guys talk about with the double number line?
Well, we saw that every time x increases by 1, y increases by a, and that's just consistent throughout. So every time like an additional increase in x happens, there's like a linear progression of a.
Perfect. So they were working with the equation y equals ax. So as x increased, we were just adding a constant amount of a, which was, what's another name for a in that equation? Yeah. Sorry.
Slope.
Slope, right? So and the slope, you know, is a constant rate. So the linear equation is increasing by a constant rate every single interval, right? So if we dealt with, if we wanted to do intervals of x plus 2 each time, so we're going double the interval, is that going to change the constant amount that linear equations grow?
No.
Perfect. So it doesn't matter what interval we choose, it's going to grow by an equal rate each equal interval, right? Thumbs up if that makes sense? Perfect, thank you. And then let's move to double number line. So screen 9, anybody that worked with exponential functions want to share what they discussed with in terms of exponential growth? Yes, Connor.
So what Juan and I noticed was that with each increase of x by 1, you multiply the y value at that time by another factor of whatever your base was. And then when the y-intercept was different, not 0, we noticed that, or it didn't really change, like, the growth. The constant was just there still, I guess.
Perfect. So I love the word you used, which was factors. So we know that exponential functions, no matter what, over equal intervals are going to